Okay, we'll wait 3 more minutes for everyone to get here, but just as a quick reminder, we are going to be just recapping some stuff that you did back in year 9, just so then we can finish off the year with full mastery in all of paper 1. So it would be useful for people in year 9 to have a look at this, year 10 definitely, and year 8 if you want to get ahead. Can't hear. Can you hear now? Okay. Sorry about that. Just to recap, basically, energy is the ability to make something happen, to do work. In physics, we have this vague definition because there are many, many different types of energy, such as kinetic energy, gravitational energy. But anytime there's like a change that is happening, like whether you're changing something to do with the object, such as its position, its speed, anything like that, there needs to be energy involved to make that happen. And we call that change, that making something happen, we call that work. And there is a way that we measure energy. So any sort of time that we have like this quantity in physics, we usually have a unit to go along with it. Just like we measure length in meters and centimeters, just like we measure your mass in grams or kilograms, we have a measurement for energy. Maybe you might remember what this is from back in year 7. Really great job if you do. But if you don't remember, we call it joules. It's spelled quite interestingly. It's spelled that way. We call it joules. And we can shorten joules instead of needing to write it out every time, just like we shorten centimeters to cm or meters to m or kilograms to kg. We can shorten joules to just being J. So for example, let's say I use 10 joules of energy, I would write I've used 10 J of energy. So I don't need to write out the full unit of measurement. Now, whenever something happens, like say you lift your phone up from your table up a little bit because you want to text someone, you're using energy to do that. So you ate some food, digested it, that gave you energy, and then your muscles use that energy to lift up your phone, and you increase the phone's gravitational energy. We'll talk about all these different types of energy in a second, but the main key thing is that energy can't come from nowhere. If you don't eat food, well, your body's not going to just come up with energy in order to be able to go for a run if you don't eat anything. If you don't have any chemical energy in your batteries, your torch won't work. If you don't have energy like going through your hob, you're not going to be able to cook anything. You need to have energy come from somewhere in order to make something happen. And this is where the law of conservation of energy comes from. If this law didn't exist, if we were actually able to make energy out of absolutely nowhere, the world would be completely different. Just because, the electricity that we use, we won't need any more energy resources for it. Things like that. But unfortunately, there's no such thing as a free lunch in physics. We have to always have energy come from a source before we can actually use it. So the law of conservation of energy is this. Energy cannot be created, so out of nowhere, or it can't disappear into thin air either. It can't just disappear. Created or destroyed, only transferred. So for example, you turn off your lights. Well, that light energy that's coming from your light bulbs, that just didn't disappear. It went somewhere. It got transferred to the environment. So that energy got transferred to your surroundings to light up the room, even though the actual light bulb itself lost its light energy. When you drop something from a height, it might have lost energy in its gravitational energy, but it started gaining speed. So we have the idea that even though sometimes things look like energy came out of nowhere or just disappeared, you always have to keep in mind that it did actually go somewhere. So now all these words that I just mentioned are all different types of energy, and it is important for you guys to know all of the different types of energy. So we start off with dividing these types of energies into either stores or transfers. Energy stores are basically, just in its name, how energy can be stored. And when energy transfers between one object to another or one object to the environment, whenever energy gets transferred and leaves an object, then we get energy that can be transferred. How energy can be transferred. Oops. So really straightforward definitions that are basically hinted within the name. So anytime you get stuck when it comes to memorizing what an energy store is or what an energy transfer is, you can always work that out from the actual name itself. Energy stores, how it can be stored. Energy transferred, how energy can be transferred. Okay, now quick quiz. You all would have done this back in year 7. So I have the types of energy described here for you already. Let's see if we remember anything. What type of energy is stored in an object due to its motion? So a moving object. I'll give you guys a hint. It starts with a K. Can we remember what that is? Type in the chat if you remember. Spot on, Beth. Spot on, Sean. Well done. Well done. Kinetic. Very good. Don't worry so much about spellings. When it comes to your exams, the rule of thumb generally when it comes to spellings is if I read it out loud and I sound it out and it's correct, like for example, I noticed some of you guys spelling it with a K-E instead of a K-I, I would still mark that correct. That would still be correct because I sounded out kinetic and it does sound like it. So that would be correct. But obviously try your best to get the correct spellings as much as possible. It is with an I, K-I. Now what about an object stored because of its height above the ground? I'm not going to give the first letter now. So if we lift an object up, we're going to be increasing this type. Spot on, Louis. Gravitational. And it actually has 2 names. Gravitational potential. Stored in an object that is stretched or squashed. What should I write? Elastic potential. Very good, Gabby. Elastic potential. So I just want to mention something. One sort of common mistake that I notice is a few students say I asked, I lift an object above the ground. What energy store did I increase? Some students would just say potential. This is technically wrong, even though, it's technically correct. You lift an object up, you've increased its potential energy. Because we have 2 types of potential energy, we also have elastic potential energy. That would get actually marked wrong on any sort of test because you haven't specified what type of potential energy it is. So make sure that when it comes to potential energy, that you remember to be specific and say what type of potential energy you've increased or decreased. We actually have a few names for this next one, stored in an object because of its temperature. there are three things that we can call this. Heat is one of them. Anyone know two other names? Thermal is another one. And then probably, not black hole, there's a third one. Starts with an I. So we have heat, thermal, and then the last one is going to be oh, my year 10 should get this. Internal. The reason why internal is one of them is because internal energy is like stored within an object. Same goes with heat energy and thermal energy. It's like, okay, how much heat energy is within this object? And then we can call that internal energy because it's inside that object. It's due to the particles inside. We're going to go into internal energy in a bit more detail in another topic. But right now, just be concerned about, the idea that we can have three names for this one thing. Stored in the nucleus of an atom. It's in the definition itself. Can we have a guess at what type of energy that might be? Nuclear. Very good. And then once again, the last one might be, is within the name itself, stored when a magnetic object is near a magnet or in a magnetic field. Magnetic. Very good. So those are the ways that energy can be stored within an object. Okay? Now, when an energy gets transferred from an object to another object or to the surroundings, it's no longer stored within an object. So if you think about like all the ones on the left, they're within the object itself. They are stored within that object. It's not going anywhere yet. That energy is not going anywhere. But when that energy goes somewhere else and leaves that object, it can be transferred in different ways. So it can be as light energy, it can be sound, or it can be electrical. So for example, electrical energy through the wires transfers to a light bulb, and that light bulb emits light energy to its surroundings. There is another way that energy can be transferred between objects, though. It's not a type of energy. That's the main difference. That's why I have it in a special little box on its own. And it can be transferred as a force. A force is not a type of energy. Oops, I'll just say transferred as force. It's not a type of energy. So for example, you use the chemical energy in your muscles, lifting up your phone, and you're transferring your energy to your phone by using a force. We call that mechanical work, like you're doing work on your phone. You're transferring your energy to that phone in order to lift it up and increasing its gravitational potential energy. One way that you can memorize the different types of energy, because you do need to memorize them, is with this mnemonic. Most kids hate learning GCSE energy names. I have in bold here all of the different ones. So M stands for magnetic, K kinetic, H heat, L light, G gravitational potential, C chemical. I left out chemical by here. Chemical energy stored. I need to edit this. Stored in chemical stored in chemicals. That's my bad, sorry guys. GCSE, S sound, E elastic, another E electrical, N nuclear. Okay, now we're going to work on some calculations. So, the first type of energy I want you guys to know how to calculate for is gravitational potential energy. So this is the formula for gravitational potential energy. This formula, you do need to memorize it. So I recommend if you make a flashcard, for instance, you have this formula on one side, and then what all of the other oh, Mick, what have you done? Can you undo that? Jeez. Okay. So what I recommend is on one side you have the formula written, and then on the other side you know what each bit means. So EP, what that stands for, is gravitational potential energy. I'm going to write GPE for short. E is energy, and then because there's a subscript little p, is there not? Let me just double check that section on the Word document. Oh, it says there's a problem loading more pages, retrying. Hold on, let me upload it again. Actually, if you refresh the page, it should come up then. For people who are working on Word documents, make sure you download it, because I think when it comes to some stuff that went from Microsoft Word to Google, like some things don't show up on the main Google page. So if you download it, so then that way that it's an actual file instead of just online, you would then be able to make sure that you see everything. So make sure you actually download the file and then open it up as a file, and then you should be able to see then the formula. Okay. So GPE, gravitational potential energy, and because gravitational potential energy is a type of energy, we're going to measure it as we measure all types of energy in joules. Now, if something has more gravitational potential energy, it depends on three main factors. One factor is how heavy it is, its mass. If something has more mass, if you lift it up, it's going to have, let me draw this out. For example, let's say that we had a massive rock and then a tiny little rock, tiny little pebble. Let's say they were both lifted up the same exact height, but because this rock is bigger, it's more massive, it has actually stored within it more gravitational potential energy because it took a lot more energy to lift it up that same height. So the M in this formula stands for its mass, because how much gravitational potential energy it has depends on its mass. And the unit of measurement that goes into this formula is the kilogram. Kilogram. And we can shorten that to kg. As we just mentioned, if you lift something up higher, it's going to have more gravitational potential energy. So let's say that I do the same size rocks, but one gets lifted lower than the other. well, the one that's lifted higher is going to have more gravitational potential energy. So how much gravitational potential energy something has also depends on how high you lift it, which is its height. And we shorten that, and we measure that in meters, because height is a distance. We measure that in meters. Now G, this is an interesting one, because you have to remember that we do have to consider where we are in the universe. If we're on the moon, where the gravity of the moon, the gravitational pull of the moon, is much weaker than on Earth, you're not going to be needing to use as much energy to lift something up. So, if we had a giant boulder, it takes a lot of energy to lift that boulder up, so to increase its gravitational potential energy. But if you take that same boulder, put it on the moon, with less of a gravitational pull, it's probably going to be easier. That's why astronauts, they're giant spacesuits. On Earth, they actually weigh loads. But on the moon, you can see that, they're jumping and hopping around because it weighs a lot less. So what G stands for is something we call the gravitational field strength, meaning how strong is the gravity on this planet. On Earth, it's 9.81. And and we measure it in N/kg, newtons per kilogram. Right. So, bit of practice then. I should say 9.8. We'll shorten it to 9.8. Bit of practice then. Right. In the past, especially my year 10s, a lot of you have mentioned that you struggle a bit with calculations and formulas. And I have mentioned to you guys one method that I like to use because it guarantees full marks, or as many marks as possible. Some of you guys in the past may have worked with trying to rearrange a formula straight off the bat first before you substitute anything in. However, I recommend that you substitute first before rearranging. And the reason why is because for some reason, AQA gives you marks for correct substitution, but if you substitute correctly into an incorrectly rearranged formula, then you lose all marks. So under the pressure and stress of an exam situation, sometimes we can make silly mistakes when it comes to rearranging. So the best thing we should do in terms of strategy is to make sure that we substitute in first to guarantee ourselves that mark, and then work on rearranging after. So the very first thing we should always do at the start of a question, because on an exam, they might not tell us which equation that we have to use, what formula we have to use. So the first thing is to read through carefully each part of the question, word by word, and identify the values we've been given. So, a man of mass 80 kilograms. I'm going to underline that because there's a number there, and that 80 kilograms is a mass. So I'm going to make a list and say my mass is 80 kilograms. Is standing on top of a building and has 96 kilojoules of GPE. I'm going to underline that. So my GPE equals 96 kilojoules. But wait, hang on a second. Write in the chat, what do you think I have to do to that kilojoules? Very good, Ollie. I need to change it back to joules because in my formula, I need just regular good old-fashioned joules in there. I don't want kilojoules, otherwise all of my units are going to be messed up going into the formula. So I need to make sure I change that into joules. Kilo means you have 1,000 of them. So if I have 96 kilojoules, that means I have 96,000 joules. So I'm just going to write that as well. 96,000 joules. And then it asks me, how tall is the building? So I want to find the height. Height equals question mark. And then my gravitational field strength, because I'm on Earth, I'll write GFS is 9.8. Okay. Now, the first step is, remember, on an exam, I might not know what formula that I have to use. They might not have told me. I'm going to think back to what formulas include all of these values. What formula includes a mass, includes gravitational potential energy, includes height? Well, it is EP equals mgh. Obviously, during this practice, you guys obviously know this is the formula we use, but in an exam scenario where you have multiple formulas, you might not know that's the specific one. So always make a list to start off with, so then you can identify what values you need, so then you know what formulas you have to use. Now, the next step is to insert values. So we have the FIFA method: formula, insert values, fine tune, then answers. Okay? Right, next step is for me to substitute in my values, and I'm going to use the list that I made. Make sure we're using the list that you made, so then it's a straight substitution in. So, is there anything that I can substitute in for EP? I'm going to work left to right here and just sub in anything that I can. What can I substitute in for EP? Let's look at my list. Very good. EP is gravitational potential energy. I look at my list and I see that I do have a value for gravitational potential energy. It's 96,000. So I'm going to write 96,000 where EP was. Then I'm working left to right. I see M. Is there something I can substitute for M? It's alright, Mick. When we substitute things in, we don't have to write the unit straight off, just because when we write units in the formulas, it might look a little bit confusing at this stage. Very good, Beth. We have something for M. We have the 80, because M stands for mass. We have a mass value by there. And then we're going, remember that in maths, when we have like letters next to each other, that means times. So mgh means m times g times h. So 80 times, and then my gravity on Earth is going to be 9.8. And then, do I have something for my h? No, we don't. So I'm going to leave h as is because I haven't managed to substitute anything for it. So basically, so far what we've done is we've made a list of every value that we have from the question. We've written out our formula, and then looking at the formula, go from left to right, substituting in whatever you can. Anytime you don't have a value that's in your list, when you have a question mark, you leave it as is. So in the question, I'm asked to calculate the actual height. How tall is the building? So I don't know how tall the building is yet. I don't know what h is yet. I've already earned a mark now for substituting things in. Now I'm going to work on my rearranging. Another reason why I like to substitute in first is because you have a chance then to clean things up. So then when it comes to rearranging, the rearranging part becomes a lot easier, especially when it comes to formulas that have multiple letters and multiple values. So first things first is I don't really like the fact that on my right hand side, it looks a bit crowded. There's a bunch of stuff there. So just like in maths, I can clean that up, can't I? Because I have 80, I have 9.8. I can times those two together and just make it so then it's one number instead of having two numbers and then a letter. So just like in maths, use the math skills. I'm going to rewrite this. But I'm going to times the 80 and the 9.8 to give me an actual one number that I can work with instead of having multiple. Let me get the calculator app out. 80 times 9.8, that is 784. So I'm going to write 784 by here. And then times by h. So all I've done is I've just combined any numbers I had to clean it up. Now I want to solve for h, just like you do in maths. You have to rearrange by doing the opposite. So because I want h on its own, I have to get rid of that 784 that's just by there. And that 784 is timesed on. So what do I have to do in order to get rid of it? What's the opposite of timesing by 784? Divide. Spot on. So I'm going to divide by 784. This is just like you do in maths now. And because I have 784, they cancel out, don't they? But what do I have if I do something on one side? What's that rule again that you guys have learned in maths? I've divided by 784 on one side. I have to do the exact same on the other. So I'm dividing both sides by 784. So the 784 on the right-hand side got cancelled out. So I'm just left with that h by there. And now I'm going to work out what 96,000 divided by 784 is. That's 122, and then I'm going to round that to one decimal place. I'm going to say 122.4. So h is equal to 122.4. And then what are my units for height? Meters. And then I'm going to write in brackets just to show you don't have to do this step, but just to show that it's in one decimal place. Sometimes questions ask you to round it to a particular amount of decimal places or significant figures. But in this question, because it doesn't, I just chose it myself, just so then I don't have to write a long list of numbers. So just to recap, first from the question, I just summarize the question and make a clear list of all the values that I have in order to know what my numbers are, to make it easier for me later to substitute things in. And also, just in case there's a question that doesn't tell me what formula I need to use and I want to work it out, it's a lot clearer if I write it like a list like this, so I know exactly what values I've been given. Next step is for me to write out the formula, and then I just look at the formula and directly substitute things in depending on what I have from my actual list. And any time that I see my question mark that I left by there, I'm just going to leave that letter as is. Then I clean it up a bit, make sure that any numbers that you can combine into one by doing a times, add, or whatever the formula might ask you to do, you clean it up, so then when it comes to rearranging, it makes it a lot easier, and oftentimes you can do it just in one step then. Then you rearrange by doing the opposite and then making sure you do that on both sides, and then calculator for the final answer. Okay, so now, just because I want to be able to get as much stuff done as possible, on the website, instead of clicking on lesson 1 and doing energy stores and transfers, you can do that if you want to, but just because I do want to practice calculations today, if you click on the lesson 2, gravitational potential energy, there's some practice by here. On the right hand side where it says practice, there's no rearranging involved. That is just getting used to using the formula EP equals mgh. On the left side where it says rearrange, that's when you need to do the FIFA method in order to know exactly what you need to rearrange for. So substitute things in, clean it up, do a rearrange for your missing variable. And then at the very bottom, you have exam questions. In terms of what your goal would be, obviously this is quite a bit of work. You don't have to do all of this. If you just want to do a little bit of practice, I recommend doing the rearranging section. If you do a few, at least I would say 3 of the rearranging bit, and you do it successfully, I'd be really happy. If you want to stretch yourself, you can move on to the exam questions. If you need a little bit more time and you want to get some practice done first on just using the formula, then feel free to start on the practice right-hand side section. But I would say the main goal for all of us today, to be able to feel like, yeah, I know the GPE formula, I know the gravitational potential energy formula, is to do maybe 3 on the rearrange side. So jump to whichever section you feel like you want to start on, but hopefully we all end up then at the same place. And for those of you who want to challenge yourself, you can do exam questions. Okay? Right, so about 20 minutes break. We don't have to start this all now. I'm going to leave the stream on, and then at 11 a.m. sharp, in 19 minutes time, I'll come back. You can get started on it now if you want, or you can start on it later, but I'd be available to answer any questions. At 11 a.m., I'm also going to put just the numbers up for the answers, so you know what answer you should have gotten. And then you can write in the chat if one of your answers doesn't match up and you'd like me to do the problem to show you where you've gone wrong. Okay? So at 11 a.m. I'm going to show you guys the answers. And then any answers where you feel like, oh, shoot, I'm not actually getting that, I'm not sure what I'm doing wrong, let me know, and then I will do that question. Okay? Right, I'm going to leave the stream on just so then it doesn't chop in half when it uploads. Okay, I am back. So I have uploaded on the Google Drive on the website. You should see now an answers page. I'll pull that up. Oh, hang on. My answer on the left, on the right hand side, and on the left, I've just copied and pasted me doing 1 dp, but I clearly haven't actually rounded it to 1 dp. So ignore the 1 dp stuff. Do you mean time travel to the past or time travel to the future? Because they are different in terms of what is possible, what's not possible. To the past, I would say, like, in terms of our understanding of the universe, I wouldn't say that it's impossible, but based off of what we understand, not really, because in order to do that, you need to travel faster than the speed of light, which is, in terms of like human engineering, it's not something that we can feasibly do. One thing interesting actually is Professor Stephen Hawking, rest in peace, actually held a time travelers party. So he advertised this time travelers party. First he had the party in secret, and then after he printed off a bunch of flyers and everything advertising this time travelers party. So the only way you could go to the party is from the future. And no one showed up to his party. But anyway, so when it comes to the actual GPE calculations, are we all okay with obtaining these answers, or are there any particular questions that you feel like, okay, hang on, I need you to just show me how you do this? I want to pay particular attention to the rearrange section that asks you to rearrange. So I'll leave this up for you guys to do. On 3, number 3 for rearrange, is that the final answer? Hang on, let me just double check because I did this really quickly. So let me. Number 3. 5. 3 divided by. Oh, hang on. Yeah, sorry. No, hang on. I messed up on number 3. Ignore my number 3. Let me just redo that. So 5403 divided by 9.8 times 98. I must have typed something wrong in my calculator. Okay, you should have gotten for number 3, let me re-upload this. You should have gotten 5.625. Hold on. Re-uploading. Okay. Yeah, sorry. Yeah, that's my bad. I must have typed it wrong in the calculator. 5.6. Well done, guys. Thanks, Louis, for spotting that for me. Should be 5.625. Any other ones that we got stuck on, or are we okay? Right, if we're all okay, so after this week, next week and the week after is technically our Easter break. So I don't want to have like pressure for live stream and extra work over the Easter break. However, I will have everything on the website. So if you wanted to do work over the Easter break, you can. And I'll probably just upload videos directly, maybe, rather than live streaming. So you can access any materials, and I'll put links on the website to any additional videos you can watch if you want to do some extra work for it. In terms of when assessments are going to be, the assessments should already be put up on, not the assessment itself, but the typical schedule of what you guys need to be covered and when by should already be put up on Show My Homework. I believe, apologies if I get this wrong because this is off the top of my head, but I believe that our next set of topics will be on the 20th. So I want to just quickly put YouTube videos up for you guys to be able to cover the digestive system. So just to clarify what is expected. So Year 10 double award, you have 2 topics that you need to cover. One is electrolysis. I'll put videos up for that. One is for communicable diseases. That is biology. You have resources on Kerboodle for that. And I will also put up, if you want to do notes, I'll put up notes organizers just as a guidance, because like I mentioned yesterday, Caboodle might be a bit overwhelming because when it comes to like a textbook, you guys might not be able to, like, you see all this information and you might not be able to summarize and extract it. So then, and the notes organizers, I've rearranged them to make it based off of Caboodle. So you should be able to fill it in just with Caboodle, even if I don't, do it online with you guys. So this is like, you should be able to fill it in yourself. So that is based off of and structured based off of Caboodle. For year 9s, you're going to be assessed on the digestive system in around 2 weeks' time. And that's basically just with a little attached test online, and then you submit that back either via email, or there should be a section on Show My Homework for you to attach a document. Once again, use Caboodle as a resource. The login instructions are already on Show My Homework, and top up your learning with Seneca, just as quick quizzing yourself, because you can, do 5 minutes here, 5 minutes there, just to stay topped up. And my videos are just as a supplement for guided practice in case you're stuck on anything, to make sure that you enter next year with confidence. Okay? So if you do any additional practice, feel free to email me questions on Show My Homework. I might not be able to respond to your email straight away, but I should be able to within the day, because I check my emails quite frequently. So even if it's a small question, or even if it's I did this problem, I found this problem that I did online, I'm not sure where I went wrong, or I just need you to check it for me, feel free, because we're in unprecedented times. So take care. Make sure you're taking care of yourself, both mentally and physically. And I'll see you guys whenever I see you. But I definitely miss teaching you all in real life. Goodbye.